Hi dear students, today we are discussing a very important section in the chapter continuity and differentiability, that is logarithmic differentiation. As the name implies, this differentiation is about using some logarithmic rules. Before that, let us see something. Right, we are defining a function as power function. See, let us see what are power functions. A function of the base index form, a base index form in which both base and index are functions are called a power function. For example, when you write x power x, sin x power cos x, y power tan x, you see that when you write x cube, when you write x cube, base is a function and power x cube, 3 is a number, right? I am not discussing like that. X power x, both base and index, both are functions. See the next one, sin x power cos x, both are functions, right? Y power tan x, both in base and index, both are functions. Such functions are defined as power functions. This logarithmic differentiation is exclusively used to differentiate power functions. What I am indicating here is, what I am thinking here is, by defining such a way, this will be easy to pick it from the question paper. When you are asked to differentiate in none of any of the question paper, it will not be given that use logarithmic differentiation. Okay, it will be given simply that differentiate. Then how to differentiate? When you have to apply logarithmic differentiation, you have to easily pick from the question itself by seeing a power function where both base and index are functions. At the spot, spark it, that we have to use logarithmic differentiation, right? To differentiate a power function, we should use the power rule of logarithm. What was the power rule of logarithm? Log x power n is equal to n log x. Log x power n is equal to n log x. Such a differentiation using power rule of logarithm is called logarithmic differentiation. So what we are going to use is power rule of a logarithm to differentiate a given power function. Let us have a problem here. Differentiate the simplest of the problems in logarithmic differentiation. Differentiate x power x. So let us consider y equal to x power x. What you have to do is applying log on both sides. Applying log on both sides. Why we are applying log here? Because the right side is a power function. We have to apply power rule of logarithm. Apply log on both sides, we will get log y is equal to log of x power x. That means log y equal to, now right side log x power x, apply the power rule, the power x, this x comes in front of the log, right? This comes in front, becomes x log x. Log y equal to x log x. After applying power rule of logarithm, directly differentiating both sides with respect to x, we get d by dx of log y is equal to d by dx of x log x. D by dx of log y implicit, because we are differentiating a function of y with respect to x. Apply implicit differentiation, derivative of log y 1 by y, because of y dy by dx. So 1 by y dy by dx is equal to right side product rule, x into 1 by x plus log x into 1, or dy by dx is equal to y into x into 1 by x 1 plus log x into 1 log x. So y into 1 plus log x. Finally, you replace y. What was y taken as? X power x. Therefore, we can conclude that dy by dx is y into 1 plus log x is x power x into 1 plus log x. Let us see one more problem. Logarithmic differentiation, one more problem. Differentiate sin x power cos x. This will be the question, okay? Differentiate. How will you think that logarithmic differentiation is to be applied? See the function sin x power cos x in the base index form where both base and index are functions. So let us consider y is equal to sin x power cos x. What we have to do is, let us take a log on both sides. So log y is equal to log of sin x power cos x, which implies log y is equal to, applying power rule of logarithm, the power comes in front. So cos x into log of sin x. Now let us differentiate both sides with respect to x. We get d by dx of log y is equal to d by dx of cos x into log sin x. D by dx of log y implicit 1 by y dy by dx is equal to right side product rule along with chain rule. Cos x into derivative of log sin x. 1 by sin x into cos x. Derivative of sin x. Plus log sin x into derivative of cos minus sin x. Therefore, dy by dx is equal to y into the whole cos square x by sin x minus sin x into log of sin x. Replace y, it is sin x power cos x into cos square x by sin x. 1 cos x by sin x gives cot x, 1 cos remains. So we are here at the answer sin x power cos x into cot x into cos x minus sin x into log of sin x. Let us see an important method, UV method. This is expected to be a sure short question in the annual examination. UV method. Why we named like that? Just you will see. Differentiate tan x power sin x plus sec x power tan x. What we can see is that we have to differentiate tan x power sin x is a power function, sec x power tan x is another power function. So here we are asked to differentiate sum of two power functions, right? Therefore, this method, UV method, is to be applied when it is asked to differentiate sum or difference of two power functions, two or more. It can be any number, okay? 2, 3, 4, any number of power functions. When we are asked to differentiate, we will use what? UV method. So let us consider y equal to the whole thing, whatever it is given. Y equal to tan x power sin x plus sec x power tan x. Then let us consider u equal to one of the power function, tan x power sin x. Now let us proceed whatever we studied. So implies taking log on both sides. Log u equal to the power comes in front, sin x log tan x, differentiating both sides. 1 by u du by dx is sin x into 1 by tan x into derivative of tan x sec square x plus log tan x into cos x. That means du by dx is u into, what was u taken as? Tan x power sin x into sec square x by tan x 1 by tan cot sin x into cot cos, so cancels, sec x simplifies to plus, cos x into log of tan x. Next part, we consider only one part, tan x power sin x. Another part, what you have to take it as v. So one part is taken as u, another part is taken as v. That is why this method is named as UV method. If there are more terms, more power functions, you have to take u, v, w like that. Okay, it's a chain. V. Continue the same process. V equal to sec x power tan x implies log v equal to the power comes in front, tan x log of sec x, differentiating both sides. 1 by v dv by dx is tan x 1 by sec tan x plus log of sec x into derivative of tan sec square x. Finally, dv by dx is sec x to the power of tan x into tan square x plus sec square x into log of sec x. Now let us come here. Let us come here. Y equal to what? Tan x power sin x plus sec x power tan x. Now this is taken as u. This is taken as v. That means basically y becomes u plus v. Okay. Y equal to u plus v. Therefore, dy by dx is equal to du by dx plus dv by dx. Substituting both dy by dx from the first box, dv by dx from the second box. Here we are completing dy by dx by UV method. So here we are completing dy by dx by UV method as du by dx plus dv by dx. Substitute du by dx and dv by dx. We can solve such a problem. When the pick is, the importance is, the stress is laid on when you have to apply UV method. We will apply UV method when we are asked to differentiate a sum or difference of more than one power function, 2, 3, any number of power functions are asked to differentiate. Try the other problem.